So in this video, I am going to demonstrate the basic features of the GenePalette program. So when you open up the program, there are four main displays. The first is the sequence display, the second is the markup view, the third is the graphical display, and the fourth are these tables. And you can shift the amount of space that each of these parts occupies in the interface by pulling down these movable sliders. The program comes with one sequence file that can allow you to explore the features of the program. If you go to the File menu and click Open, you can open the sequence called HLH-M gamma. It is a part of the enhancer of split complex of Drosophila. Once I've loaded the sequence, you can see that the graphical view displays the gene region that has been loaded. The sequence view shows you information about what sequence is loaded. This sequence is 55,826 base pairs in length, and I can go in and select parts of the sequence directly from the sequence view. Furthermore, and you can see how I can select sequences up top, and it is shown in the graphical view. So the graphical view will zoom in on any of the region that is selected as you're working through things. The graphical view is clickable as well. So I can click on any exon and it will highlight and select it in the sequence above. And I can box regions to look at things. And you can see that as I box regions, it begins to show features of the sequence in the markup view. The markup view is very useful for looking at individual sequence features. For example, in this intron, I can see this is the beginning of the intron. There's a GT, and then there's a splice acceptor sequence, the AG. So I can use that to basically look through the different features of the gene. For example, I'm going to focus here on the ATG of this gene called Groucho. And you can see the first three letters that are coded here are the first three letters of first three nucleotides of the coding sequence. And the untranslated regions are shown in gray with white text. Now the sequences in the markup view are clickable so that I can go in and begin to figure things out and see where I am in the markup view. Now the real power of this is to use features, and features are used and found in the library system. You can curate your own libraries of features. The program comes with a simple library of restriction enzymes, as well as this tutorial library, which allows us to look at the binding sites for different transcription factors that are known to bind the enhancer of split region. This gene suppressor of hairless, protein suppressor of hairless, which mediates the notch pathway, and these proneural E-boxes. These are transcription factors that regulate neuronal fate. And if I look for these E-boxes and suppressor of hairless sites, you can see that they're then displayed on the DNA. And this is very powerful because this allows us to look through the regulatory regions for potential binding sites that might be important. And so I can take a look at these regions and see how the sites are disposed on the DNA. Now, if I wanted to make some primers, I could go in and select a region. Usually a primer is about 20 base pairs, 20 to 24 base pairs in length. 22 is a nice good compromise. And I can look at the sequence features of that primer and determine whether it would make a good primer for amplification. So you can see here, I see the base composition at the bottom, the melting temperature, the GC percentage. We usually try to use 50% GC for our primers and have a good distribution that includes all of the bases. So I might move around here if I was really looking for a primer that would amplify well. So let's see how this region would work. Sequence PCR primer stats. You'll also notice that you get the forward version of the sequence as well as the reverse. This is a GC 33% not a very good primer. So I would be looking elsewhere, or perhaps using a suboptimal set of primer parameters to design these primers. The final thing that's very useful about the primers is that it does show you the reverse complement. So here I might go for this high GC primer. And if I wanted to put this onto the sequence and make it a feature, I could go to the feature library, feature menu, and add this as a feature. I'll call this my primer forward. And I might want to choose a region flanking this to make a complementary primer. So I would go in and select a region that I thought would match in GC percentage. Go up to my sequence, PCR primer stats. A little high, but let's try it out. 63%. I'm going to copy the reverse complement to make the reverse primer. Feature menu, add feature. My primer reverse, and add that in. And now I can see my design, and I can go to the file menu and save this, and it can become a persistent file that I return to as I continue my cloning project. And that is the very basics of the GenePalette interface for you.